Okay. Welcome to IT Security Labs, everyone, and thank you very much for joining me tonight. I'm very excited to be messing around with the Confluence vulnerability. So if you're not familiar with this, there is a new vulnerability. It was a 0-day. Now it's no longer a 0-day. And it affects Confluence, certain versions of Confluence, actually. Let me find them for you. And our job is really to try this vulnerability, see how attackers are using it, and then be able to understand if you are to deploy any detection rules, what should you do? So the CVE assigned to this vulnerability is 2022-26134, and this is really a very easy remote code vulnerability, and it affects. Let me make sure that this is muted. Hey, thank you all for joining. I really appreciate everybody who is joining right now. Highly appreciate you. So, what it affects really is this package here. And this is called an OGNL injection, or Object Graph Navigation Language injection. And it takes advantage of this express language that is used with Java. So this is going to look very similar to like the log4j or some other injections that involve Java most of the time. And if you craft a request in a specific way, which I'll show you here, you are able to actually communicate with the operating system, because Confluence uses the express language that is used for Java objects. So that's our vulnerability. This is a software that is used in Confluence. I went ahead and installed a Confluence server. In fact, I installed two of them. One of them is running in Windows and another one is running in Linux. And it's just a trial version. So the first thing that I needed to do was identify what can I do to try this vulnerability. Now that I know that it affects this language here, what's up with this CVE? I found a really nice, almost like a gold mine on Reddit about it. And it has all kinds of articles, so you can go ahead and read almost all of these if you wanted to. Most of them tell you about the vulnerability, and these are the versions that are fixed. But tonight, our main goal is, can we exploit this vulnerability? And if we can, what can we see in our intrusion detection system or in the logs? And can we create rules to detect it? And in addition to that, maybe for fixing, update to these versions of Confluence. So let's answer the first question. Can we exploit this vulnerability? The first thing that you do after you have installed is you go and look for proof of concepts. So here's a proof of concept for us. It's a Python script, but I'm not too excited about the script itself. It was written 7 days ago. I really want to know what's happening here. What's the deal? All right, how do I take advantage of that vulnerability? So I like to expand these. And looking at this here, I see a bunch of URL encoded data. So that's not exciting. But according to this, they ended up running the command ID. Okay. So we need to involve URL encoding at some point, right? So they're like, okay, here's how you exploit multiple targets. But this is the code that they ran to URL encode into things. So we're going to do this by hand the hard way. I actually found it. This is a URL encoder here. I found a better version of that exact POC. But in this case, I hope you can see this. I hope it's not too small. In this case, this one actually includes the class name here, and this is the class name that we are exploiting, and the method is getResponse. We are going to be getting our response as the X command response right here. Again, they're defining some class names. I don't even understand how most of this works, but what I know is there is a place here where you can inject commands. So let's do the command ID. If I encode that, this looks similar to what I saw in the POC. Or they didn't encode it all the way like I did. All right. So once I encoded the command ID, I'm going to send this using curl command. So I can say curl. I like it to be verbose on HTTP 192.168.38.237. That's my Confluence server. Then port is 8090. If you're looking at this, you're like, hey, I have no idea what's happening. I'm just piecing together a known proof of concept with my server and just try to see if it works. URL encoding makes sure that the data is maintained, the integrity is maintained as the data is moved across the network. So let's see. All right, so this one didn't like to work. So I see it's not there. All right, let's try one more time. I have the same one, right? No, not there. All right, this is the same exact command. In this case, I'm running the command ID as well. We'll decode this once it runs. All right, this is the response I was expecting. Oh, I think I know what I made a mistake on. I forgot to put a / here. All right, there we go. So our encoded text now brings us the user, the response for the command ID Confluence. Our main job is, okay, what just happened here? We reached out to a server using the curl command, and we have this specifically crafted POC that says, hey, this allows us to execute the commands. So the commands get here by abusing the expression language here for Java, also known as the object graph navigation language. That's what we are actually abusing here. So if you look, we actually get here for the user. By default, Confluence will run as the Confluence user on the system. So this is what we get. What does this look like on the wire? Let's go to our intrusion detection system, which is Security Onion in this case. We're going to go to Kibana. We want to see, can we see this? What does the traffic look like? Because the attack here, as you can see, is very trivial. It's not exciting. It's just like, hey, this language allows you to run commands. But our job is to really go and find out, what does this look like? We know what we're sending. We're sending URL encoded data. Then I'll finally show you like a Suricata rule that we can update here on our sensor. Right, so first of all, we're going to go back to our decoder and decode this whole thing here. By decode it, I mean we're going to talk about it in detail. Okay, first, this $sign and then the opening bracket is a telltale sign that, you know, this is actually this injection. You can look for like class.name here, but people change this to be something else. But almost all the time, soon after our attack, there's a / and that $sign. Let's look in Security Onion quick. I'm going to search for that traffic. Let's do a user agent. That's the easiest one. Was that's the one that I'm using. Can I find that traffic here in Security Onion? All right. So this is our host-based intrusion detection system. The traffic that I'm looking at here is most likely going to be traffic that was seen moving across a network. if you're not familiar with host-based intrusion detection systems, I highly encourage you to set up Security Onion. You'll be able to see traffic the way I'm seeing it right now. And I have videos, like 10 or 15 videos, that will show you how to set this one up from scratch. So please make sure to set up your own lab. It's free. You only need your own hardware and you'll be good. So this is the traffic that I was sending. Source IP address was 192.168.38.186. That's my, wait a second. This is not the correct one. I need this one. 186 is my Kali Linux, and it's reaching out to my Confluence. So for those who manage intrusion detection systems, this is what you are looking at. It's in the http.uri tab. If you are to create a rule to detect this traffic, you have to look at this. Which parts of these are so unique that you can actually create a rule for detection? This is where it will be. But for me as an attacker, I'm now interested. I know that when I send my traffic, it's going to look like this. So I need maybe to hide. I know that people are going to be looking for the opening bracket. Maybe I can change that somehow and not have that opening bracket if I can, or trick it with something else, maybe a square bracket if it works. So that's really important for us here. But the attack happened. We see that this is the data that we saw. This was trying to actually send us a response here. The user agent doesn't matter because people can use browsers or anything like that. But really, this traffic here is what we are looking for. Let's pick another one. All right, so this was coded by Zik. And this looks exactly like what we were talking about, actually. It's the same one. But this is the actual command that was sent. You see here, it sent, let me move it up. Right here, it set the ID command. So we can see the command, even though we URL encoded it, this time we can actually see that it's being decoded in our intrusion detection system. So the attack, for those who just joined, was very simple. It's sending a curl command with -v, and our payload, which starts here, which we URL encoded, and this is what it looks like. I'm using this website here because it's encoding those brackets for me. All right, so let's change something here. Let's verify that this is actually working. So instead of ID, let's put who am I. Heck, we even try to put a reverse shell there. All right, so now we have one with who am I. I'm just expecting one word here, Confluence. The easiest way to do this is probably with Burp Suite, but I prefer curl because I can see the response faster. 237. I'm going to point the same exact exploit towards the Windows system and see what happens. Okay. Oh, that's interesting. I don't have access to access that resource. I don't have permission. Let me see what I did wrong there. I forgot the port. (192.168.38.237) on port 8090. Then let's go. All right, so we got another response. This time we ran who am I, and just told us Confluence. So this is confirmation for us that this is actually working, and we can see a lot of things that are happening here. So thank you all for being here. I see BT, Kofi, Menjin, Timmy, Xroid. Thank you very much for being here. If you want, please download the free version of Confluence. You will be able to do this. So the one that I was attacking so far is running in Linux. So it's this one on 237. It's a live Confluence software. People use Confluence for documentation and keeping up with company stuff. And for this exploit to work, you don't even need you don't even need credentials. The version that I'm running is 7.17. All right, so that's on Linux. Let's check out the one in Windows. I'm just refreshing this. The one in Windows is a little buggy, by the way. I don't trust it that much. I tried it and I'm not sure why, but it's 7.17 here. So the command ID works in both Linux and Windows. So let's run that. I'll just go back to my URL encoder. Instead of saying who am I, oh, who am I also works in Windows. Who am I kidding? Let's just use that. Let's use curl-v http 192.168.38.119 on 8090. So now we are going after Windows. All right, so this one didn't work. I know why. I always forget this one. I need a last /. And let's see if this one finishes. For Windows, it doesn't talk. You see this response here? I should be seeing a response. So who am I did not work for Windows. But I know that if I do something like a ping or something like that, I'll be able to see this. In fact, I should be able to see this traffic anyway in my IDS. We can actually still try to update our response. Just because we didn't get a response doesn't mean our command didn't execute in Windows. So we can still try to put a reverse shell there if we wanted to. Let's see if the one for Linux is still working. Awesome. Hey, Extreme Paperclip, thank you for joining. Really appreciate you being here. You just joined as we attack Confluence here with the latest vulnerability as of like a week ago. And as you can see, the actual exploitation, like I said earlier, is just trivial. So we just have to make sure that we keep up. Let me check my alerts in Security Onion here to see if anything showed up. Of course it didn't. Actually, the only thing we saw is this 400 code here when our command failed. So the 400, it's a user-generated error. I hope we can see the command that we ran. Yeah, right there. That's our command. That's the log file that we see with the get for %200. If you really like to work in cybersecurity and be better at things, being able to quickly and effectively go around and read logs and just understand, oh yeah, this is the traffic that I sent, this is what an intrusion detection system presents it as. The more comfortable you are with these things, the more you are likely to focus on things that actually matter, like looking at the detection rules and making sure that they're working correctly, or evading detection rules if you're a red team member or something like that. So unfortunately, the only thing that fired for us is this 400, but it does contain our traffic, which is interesting. However, I have a hunch that we can actually add a rule that will actually detect this. So far, this 400 is not working for us. Next, for those who will be implementing this in prod, you want to go to your Confluence server. So in your Confluence server, in this case, this is the location for the logs where you want to have your logs in place. So it's in the OPT. I'm running mine in Ubuntu, Debian. So in here, I just cheated. I was like, hey, can I just cat everything and grab me java.lang, which is part of what I was doing here. It's one of these words here. I just picked a random word from here. And look what we see. Actually, there we go. This is also showing on the actual host itself. This is our URL encoded data that we can see here. So what does this show us? It shows us that with our wazuh agent, we can also monitor these logs. I did not do it in my lab, but when I found out that in these logs, I can actually see what's happening here. If I were managing this in production, I'll go in a wazuh agent and say, hey, if you see this java.lang with maybe the beginning of this line here, which is a curly bracket right here, then I'll need an alert to fire. This is how we can figure things out. So in this case, I'm not monitoring these logs, but I do have a wazuh agent running, which is interesting. So that's the log file. I'm not sure which of these, but I think it's this. Here's an access.log. Let me see if this one tells me. No, it doesn't. But here, we can tell that this is a curl agent that was used. So both our intrusion detection system and our server, they would tell us that this is happening. So for detection purposes, we would have to go and add those alerts here. All right, so let me know if you have any comments in the comment section here. I'm curious if you have anything that you want to add here. But this is kind of exciting for us. All right, so another thing that we can look at while we're at this, you know what, let's weaponize this. I won't go crazy with the weaponization, but let's weaponize it better. First, I'll ask the server, hey, do you have netcat? All right, let's ask it from here. I'm not sure if we'll get our response with the the single quotes, but we'll find out. Okay, let's do that. Come on, site, encode my stuff. All right. So once we encode that, let's ask the server, hey, do you have netcat? -v http 192.168.38.237, I think, on 8090. All right. Moment of truth. And we got a response. So this response that we see here is the same response that I got in the actual server. It says, hey, I got netcat. So what do we do here? Let me know in the comments right now. We have netcat. We can run commands on a server. What is the logical step that we can take here to finish this server off and make sure that it works? If we can pull it off. Sometimes it doesn't work. Let me know in the comments while I pull my notes. Somebody mentioned the OSCP. I still have my OSCP notes in here, so let me pull them up. Which website do you normally go to get your payloads? Oh, the top of my screen is not showing. There we go. I fixed it. No, I'm not root. I'm Confluence. So so let's go ahead and weaponize this and get a reverse shell, hopefully. So we're going to go to payload all things. Yeah, let me just bring this one up here. So you want to type payload all things or payload all the things. And then you go there. This is our one stop for all things payload. Metapredator shell. I'm not a big fan of Metapredator shell. I do know how to use them. It's just that they are really not my thing. Okay, so we have netcat traditional. Let's stick with the traditional, right? So we say, hey, netcat execute bin bash for this IP address here. Another website that you can use is Rev Online, I think. I kind of used this one during my OSCP as well. This online reverse shell generator. Was then all I could do was, hey, I would like for you to give me 192.168.38. Then go back to your Kali and you're like, hey, what is my IP? IPA 38.186. Port 555. I guess we're doing that. Then we're like, hey, I need netcat -e. So it's the same thing that happened as if you ran in the other side. So let's use port 555. And now we're going back and we'll be like, hey, can we remove which netcat? Replace with that. So move that and encode it. I have not actually gotten a reverse shell, but I don't see why it wouldn't work. Or maybe the encoding might be off. So here we go. Back to Kali. Let's do a couple of things here. Let's split horizontally so we can see side by side. At the bottom, I'm going to start my listener. Netcat -LV and P says, listen, be the boss. Numerical port for 5555. Curl -V HTTP 192.168.38.237.8090. Now let's paste our payload up here. I don't have my hacker mask. This is moment of truth. Let's see. I don't know if it worked or not. That went too fast. All right, so the one thing that I can think of is our URL encoding didn't work as much as we wanted to, because this connection didn't work. Maybe. Okay. So I know for sure that it's the URL encoding that's messing with. Oh, come on. Somebody didn't tell me. I can actually do encoding here. That's nice. Oh, I can encode from here and send it in pre-encoding. Double URL encode. Now that's nice. Okay. So the only thing that I messed with was I didn't put bin bash, I put cmd for Windows. Okay, let's do it the right way. I like that website because it actually does URL encode for me, which is nice. So I want bin bash here, not cmd. So encode my payload. Now copy that. Curl -v http 192.168.38.237.8090. All right. Paste. Then let's put the leading // enter. All right, I've got a 400 bed request. What could have happened here? 8090. All right, I'll try one more thing here, then I'll give up. We need to URL encode our netcat so that it is actually better. So here's what I'll do. If I URL encode it once, I can have this. This is part of hacking, right? we gotta figure things out. It's worth trying. I'll URL encode it, then put it here. Then I'll URL encode it again, because you can double URL encode. No, there are no rules against that. Okay. There we go. Now I'll encode the entire payload by itself. So that section will be double URL encoded. I don't know if this will work. If it works, I would have found something for myself. 3 HTTP 192.168.38.237 on 8090. And that. Looks like I made some progress this time. Yeah, I did. Except it didn't call back. Okay. Cross-site scripting mode is on. So we can try other things like Python as well, if this doesn't end up working. But for now, as long as we can verify that this runs, that to me is all I care about. Let me see this. And look what it looks like. Oh God, what's happening here? All right. All right, so we URL encoded and we didn't get a reverse shell, but we are getting the commands. So just to make sure that it actually works, I'm listening on 555. I just want to go back and see if Netcat will run as a user Confluence. All right, so we are in as Confluence. Can Confluence run this? Maybe we're just hitting on something that doesn't work. Okay. Usage. Oh, I see. Doesn't like -E? What are they talking about? So it's the syntax, it's not the command. Can I do that? No. Okay, so I have an invalid option here, which is weird. So it will listen. Let's go the other way. Let's go the other way. So Netcat will listen. I don't know why it's not talking. What it's talking about. All right. My proof of concept is going to say I'll have it listen. Then I'll run the other command the other way. You think -E is getting wrongly pasted? Like the minus. I don't know what he's talking about. All right. We'll do the bind shell instead. But I'll verify that very quickly. See if it works or not. Welcome to Reverse Shell 101, right? All right, let's see. Okay, so we are capable of receiving the other way. I don't think it's the firewall that might be blocking my port going the other way. I was about to give up, but now I don't want to. Yo, give me a bind shell. With netcat. Wants to give me PHP. Jeez, I got another spammer. All right, I have no idea why this is happening. I might move to just bash. Forget netcat. We got bash. All right, we're going to inject a bash reverse shell. Go back here. We remove that. Open quote. Paste, close quote. Put our IP address here. Which is 192.168.38.237. Forget 4242, that works for me. Encode that. This happens all the time where one method doesn't work, but the other one works. All right, so back to this screen here. For 242. Let's copy this entire string and run our curl command one more time. Then after this, whether this works or not, we would like to go through a Yara rule, not a Yara rule, a Suricata rule that might detect this. -v http 192.168.38.237.8090. Finish that. Whew. 400. He really didn't like that one. 8090 for name. Okay. Let's see what netcat they have. Okay. Length. They don't have -e actually. Enable debugging, pass. Okay. Start listening on specific port. Netcat -l. Okay, so this is our syntax. Okay. There is no -C or -E option in this netcat, but you still execute command after connection being established. Okay. Oh, that would be nice to know. So we don't need the -E option. I'm going to try netcat one more time, then we'll be done with this. 38.237. All right, on 4444. Let's encode that. Come back here. This is the last time, I promise. Cancel that. Control C. So instead of 4242, I just put all fours. And one last time, curl -v http 192.168.38.237 8090. All right. Oh, apparently it doesn't actually send. I don't know why it's not sending the correct. Except I think that it has something to do with URL encoding, especially with this netcat section here. We'll edit some numbers, so it's not reading it correctly. But at least we know that the exploit works, and we're getting the basic commands like who am I, ID, and all those things. As the other one. As far as netcat or any other ones, it's just a matter of trying all the different options. But without wasting too much of your time, let's talk about our detection, because really we want to be there for detection, right? So in security onion, we need to verify that all of our intrusion detection system components are working. You see it says okay on all of them. That's good stuff. But I also have a rule that I was messing with before this started. In fact, I have two rules. I found these on the internet. Oh yeah, BT is probably right. You know what? I don't know what I was thinking. Firewall D is not running as a status. There is our problem. That would do it. All right, so of course we have a firewall. We have a firewall. All right, I'll come back to the rule. That's what happened during the OSCP. You don't use it. If you don't use an open port, you get nothing. And I forgot about it. I don't know if that's the one, but we'll find out. UFW is loaded here. So for sure, we have problems. Okay, let's do this. This one is open for sure. Uh, 192.168.38.237 8090. That was quick. What happened here? All right, I'll play with the reverse shell later. Because I think we have two things here. URL encoding sometimes doesn't encode these things correctly. Or I forget to put the right IP. Okay, come on. Curl minus V, HTTP 192.168.38.237 8090. Give me that with /. Oh my God. As someone who took the OSCP, I'm so mad right now. Because this is the one thing that will get you for those exams. And here I am struggling with the same thing. Thanks, BT, for saving me here. We did get a reverse shell, as you can see. We should be in as Confluence. Connect to from unknown. Am I? Come on. We did get a connection. Oh, our connection didn't say bin bash. But it said it doesn't matter. All right. So as you can see, we do get a reverse shell. That's all I care about. We do get a reverse shell, whether or not it will actually give us anything. It might need to be stabilized. So the easiest thing that we can do here is maybe use Python, which might be easier for us. But hey, I hope you learned something here. Keep an eye on your ports. So because this port does give us a reverse shell, use open ports or disable UFW firewall, the silly firewall that we have here, and things should work. Which makes me wonder, all this time when it was not working and I was not getting anything, I was curious why it was doing that. Anyway, this is how we get our reverse shell. We'll be in as Confluence. You still need to privilege escalate from the Confluence user. But whatever it's trying to do here, I don't like it. Going to try it one more time. All right, there we go. So we do get it, this silly connection here. Maybe I need to do lrep. All right, so of course this reverse shell has been logged. I hope Suricata triggered something here. Or at least the wazuh agent should have. Nothing. All right. So now let's look at this and say, do I have netcat? I'm just trying to see if I can get that reverse shell quickly. Of course, Zeke saw that. The only problem is the port that I chose is the same. So it's really not going to not help me here. Destination IP is 237, destination port. But I want the other side. Of 192.168.38.186 or 286. Uh, 8090. Okay. All right, so we didn't log the other way around. It should be 186. Yeah, we didn't log the other way around, but we see this is how many times we actually reached out to that, and we still have. Oh, there we go. I think you might like this one. So this is the one that we just ran, the exec netcat 8090 command. So that also gets caught. So for those who like the defense and also the attacking side of things, being able to see that regardless of what we do here, it's going to get logged and you can track it down in your IDS is very, very important. So what we just did here is we are abusing this OGNL object graph navigation language, which is open source and is running on Confluence. It allows us to craft specific commands in the GET request to the server and gives us reverse shell, remote command execution. And this is what we have, the one that at least we attempted to, and it gave us a reverse shell. All right. So in addition to that, I was showing you earlier that we can and should focus on security onion and the intrusion detection system rules. I did not create these rules. I borrowed these rules and I was just messing with them earlier. But let's just go through this Suricata rule very quickly. So it's an alert. It's going to look for HTTP from any source, any destination, to any destination, any port. And then in this case, the message is attack potential URI template injection. And the content that they are looking for, if you look here, they are looking for this. Let me know in the comments why this is the thing here. They are looking for $sign and an open curly bracket. Let me know what you think about this rule here. They are looking for an HTTP URI, in this case with content with that curly bracket, the closing one, of distance 0. There was one other thing. Yeah, this is just a classification. It's a remote code execution, and there is really nothing here. So I adopted the same rule because I wanted to bring it to this year. So HTTP underscore URI, I changed that to HTTP .uri because that's what my server shows me. It doesn't code underscore URI. So if we go back here, this is HTTP.uri for me. So this is how I would create a suricata rule, make sure that it runs. Let's see what else. Yeah, so I need to update my suricata, make sure that this rule is in place, and of course, if it ever runs, it will definitely catch at least this first part here for sure, because our attack, just in case you forgot, it has that same section right at the beginning, right here. So this is the section that we are looking for, the very beginning $sign and greater than sign. That's what this rule is looking for right here. I know there are other people out there who have written rules before. They might have better rules, but this is the one that I borrowed from the internet. I don't remember. I think it was on Twitter. Somebody posted it a few days ago, and I borrowed it. And I wanted to break it down and see if it will actually work. And there we are. We have a working rule. Let me know if you have any questions. I think we have covered a lot tonight, but I would definitely like to hear what you have to say. If there are any other indicators that you would like us to search for, please let me know. But for now, we know for sure that this is how we detect this vulnerability. Let's see. Yeah, it does look like a log4j, right? Because the log4j also had the JNDI at the beginning. It's the same thing. These things are almost identical as far as the detection is concerned. But the good thing is we are not calling this one Confluence. We're saying we see URI template injection. So this will catch all of them. Then it's up to you to go and figure out which one they're actually attacking in this case. All right, so once we have this rule in place, let's quit out of here. In your suricata, you need to run like a suricata rule update force. Let's see if this one will run. All right. So added one rule here. As you can see, it says we added this one rule. So let's see if it actually trigger. Let's apply this state. Then we will restart suricata. And if it fires, it fires. If it doesn't, we'll try to figure out why. And this is just how you do with Security Onion. So just know that this is where all the rules are kept. You do not touch this file. You update your rules in this local file here. That way you can keep your rules away from the emergent threat rules. So right now it says we changed to, we're using sort for auto management. Okay, then we need a restart, which is 33. Oh, come on, 23. Once suricata restarts, we're going to run our stuff again, and fingers crossed, a rule fires. If it doesn't, I don't know what will be happening there. All right, so For those who are here and you're not too experienced with like working with network intrusion detection systems or things like that, I highly encourage you to just install your own security onion and follow along with me, attack the same machines that I'll be attacking every week. Trust me, you actually just get better and better with every time that you do this. All right, so we just restarted Suricata. So the status. Suricata is happy. Time to cause havoc now. Let's go back here. I think we did it from here. What was this one doing? Okay, yeah, this one should do it. I'll run it multiple times and give our index a chance to work on it. I don't need to load last 24 hours when I can just do last 15. All right, let's see. Moment of truth. I just adopted that rule right here, so I don't know if it will run. I still see OSEC. Let's check that traffic here. Let's find our user agent of curl. In the last 15 minutes, so these are the ones that I was triggering. Do I have any Suricata? No. It's all Zik. What happened here? All right, I'll run it a couple more times. Then we'll adapt our rule next time. So I'll test this rule as well. Make sure that it's actually in place and it's there correctly and that everything is running. Otherwise, I hope you benefited from seeing what the rule should look like, seeing how we can execute commands and reverse shells, and also how you go about when there's a proof of concept out there, just implementing it and trying it out on yourself by yourself, which I think is a really, really important thing. So I hope this was helpful for you. If you have any questions, please let me know. But I highly encourage you to set up your own lab. And if you need help, I'm always there to make sure that I can help you. I'll now leave it to any comments that you might have for the next couple minutes here. And during that time, I will look at the dashboards. What did we do? This is like an assessment of after we are done. Well, first, we saw a lot of network traffic, connection events from Zik, which is to be expected. Most of this traffic was network. Suricata was kind of taking a step back. I'm not really impressed by my Suricata instance. It's not triggering as much as I would like. I have the free ET Pro alerts. Maybe it's time for me to upgrade them a little bit. HTTP wasn't even the top protocol here. So I really like this because it's like a summary of what happened. we got our spammer back again. All right, everybody. Thank you very much for being here. This is a lot of fun. Like BT said, I hope to keep doing this every Sunday. So if you really like this, if you want to learn with me, please join me every Sunday at 9 p.m. Central Standard Time. I'll be sharing some of the machines if I'm not using free trials. So we have more fun here. Otherwise, thank you for being here. And thanks for subscribing, by the way. I really appreciate you. Subscribe, like, and share this video on Twitter and tag me as well if you can, so that we can reach more people, so we can have a big community that we actually we can share with. So next time, I'm going to have BT as my moderator so that the spamming can be taken care of. All right. With that, thank you.